the atom, how the atom behaves. I'm going to share my screen and going to bring up a Bohr diagram here. Okay. So we have 14 questions today. We talked about the atom in the beginning part of the year, and I've assumed that it's kind of a little fuzzy, or it's forgotten a lot of kind of the concepts involved, but it's pretty critical to understand some of the things we're going to be talking about here pretty shortly, talking about how things go in and out of the cell, why things are able to do what they do in the cell as far as entering and leaving the cell, and kind of the importance of the different, we did talk about the macromolecules earlier in the year, but very briefly, and I don't think a lot of you guys remember them. But there's three parts to the cell. And remember, the nucleus is made up of the neutron and proton, which is, in the Neal diagram here, it's in the center. That's where all the mass is, most of the mass of an atom. Electrons are very small, 1/1800th. I've seen 1/2000th the size of a neutron or proton. Very, very, very small in mass. And the size of the nucleus is extremely small relative to the orbit of the electrons are whipping around the nucleus. Remember the analogy of the marble in the football field. The electrons would be the football, even I've heard stadium would be where the electrons are, and the little marble would be the size of the nucleus relative to the orbit that the electrons are flying around the nucleus of the atom. So again, three parts: neutron, proton here in the center. Things like the only element that doesn't have a neutron is the hydrogen. It just has one proton here as its nucleus. Again, hydrogen is extremely small. It has one proton, one electron. So it's the only atom that doesn't have neutrons. And there again, in the nucleus. So we've just answered 1 and 2 here from our little review paper. Number 3 is what part interacts with other atoms. So what part of this atom will interact with, and is the electrons will interact with other atoms. The protons and neutrons. The protons might exert a force on other atoms, but they don't share fields. They don't share energy levels like the electrons do. So that answers 3. 4, we just answered. Electrons orbit the nucleus in energy levels. So again, for our purposes, we're just going to be talking about the first 2 energy levels. For life sciences, we don't really get into the larger elements that that say like a gold will have multiple energy levels. Something like uranium is the largest element that naturally exists on Earth, and it has a really large number of electrons and many energy levels. Again, we're not dealing with elements like that. So the atom that makes up 99% of life now, life have how many, again, so that's 2, that was number 5 from your review here. How many electrons go in the first? So the first energy level here, you have 2 electrons, always 2 in the first. And so when you're talking about hydrogen and helium, and those are the only 2 elements that, so helium has 2 in its in the outer in its first ring here, and hydrogen only has 1, but all the other elements will have more than 1 energy level. The second energy level is going to have 8 electrons. You're going to have 8 here in this energy level. And again, that is really important as far as some elements don't have 8, they have 6. Oxygen, for instance, only has 6 in the second energy level, and so it wants 2 more. It wants to have 8. Remember the rule of 8. I don't know if you remember that, but that means that in this second energy level, it wants 8 electrons. What kind of charge do the electrons have? They're negative. Okay, so there's a negative charge here so if you have an ion, which is an element that has electrons, extra electrons, you're going to have a plus, or it's going to be a -2 charge because it has 2 extra electrons are negative. So that's what causes an element to have a negative and positive charge. Protons have a positive charge, and so the two are attracted to each other, and they create a force between them that keeps the electrons in place. The mass of the nucleus is what kind of an analogy would be the sun in the middle of our solar system kind of keeps our solar system together, Earth orbiting in its yearly rotation around the sun. We just did 8 and 9, which was protons, again, have positive charge, electrons have a negative charge. If an element has more electrons than protons, what type of charge? It's going to be a negative. So in a situation where if oxygen is happy and it has its second energy level filled with electrons, it's going to have a total of 10 electrons, and it will have a -2 charge. But that's what it requires to fill out that second energy level and follow the rule of 8. If an element, so we just answered number 11 there. Oh, no, excuse me, we answered number 10. If an element has more electrons, it'll be negative charge. If an element has the same number of protons as electrons, it will have a neutral charge. So if you have this number of electrons and protons, you're not going to have a positive, negative charge. So if the atom itself is perfectly happy having a neutral charge, but it does want to fill its outer valences, its outer energy level. It's called the valence electrons. So number 12, if an element has 6 protons, how many electrons would it like to have? If it has 6 protons, it's going to have 6 electrons, but that creates a problem because the outer energy level only will have 4 electrons, and so that can potentially have 8 in that outer, so it'll have a potential to work with 4 other elements that could maybe only donate one. If maybe another element has an extra electron it needs to share, say like hydrogen, it'll want to share with 4 hydrogens. That creates the gas methane. And again, we'll talk about that more, as hopefully we can understand that a little bit. So what element has 6 protons? That's carbon. Carbon has 6 protons. And that's its atomic number, it's 6. If carbon put 2 electrons on its first energy level, how many are left for the second energy level? We just talked about that. It's going to have 4. Okay, so that's the review, our first review of atoms. Those you guys are at home, you have to, this Bohr diagram here, I'll go over number 14 real quick again and say we're talking about carbon, and it's carbon here in this, it's not in this, it should be in this, because here it is. So carbon has a total of 6 protons, right? It means it needs 6 electrons. And so it'll have 2 on the first energy level, and then it'll have 4 on the second energy level. And it wants 8 on this level. As you go out the rings, you potentially can have more and more electrons as you go get more and more energy levels. But for our purposes, for life science, almost all the elements we're dealing with here only have 2 energy levels, or say if it's hydrogen, just has 1. Okay, so in this situation, carbon will want to add 4 electrons from other elements to make that outer energy level have a total of 8. Right? And so if it was interacting with hydrogen, hydrogen has 1 energy level, and it has 1 extra electron, or it has 1 electron that it can interact with other electrons. And so hydrogen will add 1 of 4 hydrogen will add their 1 electron to make that a total of 8 in that outermost energy level. So that's something that we're going to have to kind of talk about more here going into the future. So hopefully that kind of helped you guys understand a little bit about the kind of the atom, and review a little bit things we had talked about earlier in the year.